right, time for another round of Mr. Young on television, on YouTube. I have a really hard time talking online, especially when I have a wire. In fact, you can't talk about wires online at all because I just find that Discord isn't working. Discord? Oh man, I did wake up wired this morning, but it is what it is. You know, I caught my son chewing on wires the other day, and I was like, son, you're grounded. All right. I've been working on my wiretapping, but it doesn't seem to work. I can't hear anyone else. All right, let's do a little calculus, because why wouldn't we? So, I'm going to do this a few times today, but I want you guys to study many different integrals that look almost identical and be able to pick out which strategy you should be using. So all four of these have the exact same variables, exact same functions, one little teeny tiny difference, and then we're going to anti-derive. So study these briefly. And now as I peruse these, I'm looking for relationships such that I can pull off, well, what do we have so far? We've got u sub, we've got inverse tangent u subs, but those require fractions. We've got parts, three different versions of parts, but they're just parts. You can go tabular, unknown integral, or standard, or it may just be a regular old antiderivative. So in the first one, if you notice this addition sign, that's a really good indicator that you're doing just a standard rule antiderivative. The antiderivative of x is x to the second, and we need a half in front. So we're going to get 3 halves x to the second. This is a little baby chain rule, which you can do in your head. I need a half to cancel the 2 that would come out. So I get e to the 2x plus c, and voila, we are done very quickly. Number 2, I notice this is a product. Products can be chain rules undone, they can be parts rules undone, they can be standard rules undone, they can be all those things. So what am I looking for? If this were a chain rule, these two pieces would need to be 1 degree apart, and they are not. I don't see a squared and an x to the first or a third and x to the second. But this is a product, which leads me to believe that this is a parts problem. So I'm going to choose u to be 3x, that will derive away. Du is just 3, which means my hand is forced. This must be e to the 2x dx, which means v is, well, we already anti-derived this, it's right here. So don't have to do it again. 1 half e half e to the 2x. And now we just fill in the blanks and we're done. So u times v is going to give me 3 halves x e to the 2x minus the antiderivative of v du, which is 3 halves e to the 2x dx. And that is a little baby chain rule, but I'm not going to set up a u sub here. We can do it in our head. 3 halves x e to the 2x minus, I'll need another half to come in front of this, and I'll end up with 3/4 e to the 2x, of course, plus c. And there we go. Here's the relationship we were looking for before, to the second power to the first power. So this is a u sub. Standard u sub, someone did a chain rule and got this answer. We are going to undo their chain rule. So I'm going to let this power be u. du in this case is 4x dx. But I don't want 4, I want 3. So I'm going to multiply this by 3/4 on both sides, and this will now become 3. Pull off my u substitution. So this becomes dx, and this becomes, well, that's really nice, 3/4 e to the u du. Very easy antiderivative. 3/4 e to the 2x squared. And that's it, squared. It's not working very well today, this marker. It's really not making its mark. I didn't set that up, it's just not working right today. And this one I think is just a standard rule, right? If we pull the 3 out, we've already anti-derived this twice today. So I'm gonna leave the 3 in and just need a half to cancel it. And we're gonna get 3 halves, b to the 2x plus c. And that's it, gunzo. You see, this is really, this board used to be remarkable, but it's not today, let me tell you. All right, let's continue on, shall we? So 5 more sets, and let's see which strategies make the most sense. So give these a quick study for the viewing audience at home, and then we shall attack. First one, I see x to the first, x to the first. This is going to be a standard parts problem. X to the first, x to the second, there's my u sub. Here I see an addition sign, well this is just going to be a basic rule. Number 4, x to the third and x, that's not a u sub, and this takes a long time to derive away. That's a parts problem, we're going to use tabular on that. And here we have a product, and neither one of these is going to derive away. So this is an unknown integral, this is going to take a little bit of work. But the rest of these aren't going to be too bad. This is a standard UV. U is for x. Am I just writing too fast today? Maybe. Du is 4 dx. V dv equals the sine of 2x. I'm going slower now the video is going to be longer. You're welcome. And so anti-deriving this is going to be negative. Don't forget the half. That's a bad negative sign. Cosine of 2x. Ugh, this is, no, I'm starting to get frustrated. If I punch it, I'll break my hand, but I want to. So what I want to do right now. So uv half of 4 will be 2, so we're going to get negative 2x anytime now. Cosine of 2x minus the antiderivative of v du, 4 and negative a half is going to be negative 2. I'm going to make this plus 2, regular 2, cosine of 2x dx. And now all we have to do is anti-derive that guy. So our final answer, 2x cosine of 2x. I might have to pause this video and then come back. This is starting to be very frustrating. Cosine is 2. Now, it's not 2, right? We have to be careful. And even I'm getting so frustrated by the smartboard that I'm losing my train of thought here. Stop it. If I anti-derive this, a half is going to come back out. So I'm going to end up with a regular sine. When the half comes out and cancels this 2 of 2x plus c. Wow, this is ugly. Hopefully you guys can follow this at home because I'm going to switch markers and see if that helps. I don't know if it's going to. Everybody fingers crossed. I don't know. It's getting pretty aggravating here. So this one we know is a u sub. I'm going to let u equal 2x squared. And then I want du, well what do you know? Sometimes things just work out. We get a perfect match. 2x squared is 4x. So I pull off my substitution. It's a perfect sine of u. 4x dx becomes du. And we already know the antiderivative of the sine. The derivative of sine is positive cosine, so this will be negative, of course. So we end up with negative cosine of u, which is 2x squared plus c. And this marker seems to be much better. Thank you. This looks like a standard rule, up to 2, so this will just be 2x squared. Antiderivative of sine, we just did that as a negative cosine. Don't forget the chain, so negative half cosine of 2x plus c. Nothing fancy there, standard rule. This one is going to take a while to derive away. Let's do a tabular. Save ourselves the stress. U, D, V. And obviously this is the term we want to derive away. 4x to the third, 12x squared derivative after derivative after derivative until we hit 0. Be really careful with the signs, SIGN, when you set up your DVs. So this is the sine of 2x. Every time I'm going to need a half out in front. And the antiderivative of the sine is the negative cosine of 2x. I'm going to need another half in front, negative sine. And then I'm going to need another half. This will be positive cosine. And finally ending with 1/16 positive sine of 2x. And remember, we are diagonally working our way through the tabular method to come up with our terms. So this one is positive, the next one is negative, this one is positive, and our last one will be negative. So if I write all this out, I'll try to fit it into this space right here. I don't know, give myself a little bit more room maybe. So half of 4, I'm going to end up with negative 2x to the third cosine 2x. This will be negative, negative will become positive, and I'll end up with 3x squared sine of 2x. This is positive, 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 so I end up with 3x cosine of 2x. And then finally negative, positive, positive. So this will be negative, and this becomes 3 halves. So minus 3 halves sine of 2x plus c. And there we go. Would have been awful if we did the long way. It's really nice if we do it the short way. And let's do one more unknown integral because they're so fun. Am I right? Of course I'm right. So u can be anything because this will never go away and this will never go away. So let's just make it this. And that means du is the same thing. dv must have to be the other thing. And the great thing about doing this is that we've already done it, already done it, already done it, already done it. So we've already got all these antiderivatives written down. I already know this is negative half cosine of 2x. And we start our uv setup. U times v, I still get negative 2, but now I've got an e to the x here. E to the x cosine of 2x minus v du. This negative sign is going to make this a 2, and it's going to make this a plus 2e to the x cosine of 2x dx. And of course we need round 2. Since this is addition, it's going to make this a lot easier. I won't have to keep track of any signs. So off I go again. Where I stop, nobody knows. 2e to the x dx dv is cosine of 2x, which makes v, well, the derivative of sine is cosine, so this will be positive. 1/2 sine of 2x. And now we fill in our parts problem one more time. Let's bring this guy down. Negative 2 e to the x cosine of 2x. This is now plus, but when I do uv, it's still plus. Fantastic. 2 1/2 cancel. E to the x sine of 2x minus v du. The 2 1/2 cancel again, and we get e to the x sine of 2x. Now here's this weird moment. So I had this 4 here, I'm going to have to deal with that, but I can see that these things match up. So we'll deal with the 4 in a second, but I'm finished. I'm finished with my 2 rounds of parts. So this is supposed to equal the original. So I'm going to set it equal to this, and I'm going to pull the 4 in front, because that's perfectly legal. And now I'm making a nice little match for myself. Now these things are identical. And why would I do that? So that I can do this arithmetic. So I'm going to add this to the other side. When I add this to the other side, I'm going to end up with 5 of them. I'll add this guy. And I'll add this guy. 2x. And so what I end up with is 5 of these e to the x sine of 2x's equals all of this stuff. And guess what I'm going to do with all of this stuff? I'm just going to put it over 5. So I end up with negative 2 e to the x cosine of 2x plus e to the x sine of 2x. And now I'm going to divide both sides by 5, and that will be my answer. All of this over 5. Don't forget the plus c. So those unknown integrals, they are a lot of work, especially if you want to keep track of your coefficients, but this wasn't that bad. It was kind of bad. All right, one last set. I promise these are easier. I don't want this stuff to leave your brain. So one last time, I want you guys to study and peruse, and then we will talk strategy. So now we've got fractions, lots of fractions. All right, what do I see here? I see an x squared and I see an x. These are 1 degree away. This must be a u sub. I see an addition sign here. This must just be a basic. I see 2x ln of x here. This 3 means nothing. I can actually pull the 3 out. I could pull the 2/3 out. And then what I have is a product. X to the first, x to the first. So this is going to be a parts problem. And then here I see addition, x squared, and a number. This is an inverse tangent. This is a u sub, but it's an inverse tangent problem. So let's attack these really quick. If this is a u sub, the denominator has to be the u. 3 plus 12x squared, which means du, well, it's not quite a perfect match, is it? We get 24x dx. We don't want that, we want 2. So I'll multiply by a 12th. And now we have a perfect match. So we end up with 1/12 antiderivative of 1 over u du, which of course is an ln. So we end up with 1/12 ln of u, which is 3 plus 12x squared plus c. Voila. This marker's been much better. I'm going to make a nice remark about this. So anti-deriving this is a standard rule. Let's be a little careful with this, but I know this is just 2/3 x. And what does this say? This says the same thing as 1/12 x to the -2nd. If I anti-derive that, I'm going up to the -1st. And I need this to be positive when I multiply by -1, so it's going to become -1/12. So this will be minus 1 over 12x is my antiderivative. And that's it. Done. Plus c. Game over. No problem. We said this was a parts problem. You know what? I'm going to leave the 3 in, so I don't have to deal with it later. I'm just going to make this little thing my whole u. So I'm going to let u be 2/3 x. So then du is just 2/3 dx. And that's going to fail, because this we don't know the antiderivative of. That's why we need to pick ln as your u. It has to be. Every single time you see an ln, you need to let your ln be u, because you don't know the antiderivative of the ln. So this saves the day, 1 over x dx, because I can antiderive that no problem. So if dv is 2/3 x dx, we're going up to x squared, and we need to cancel that, so v is going to be 1/3 x to the second. Now we fill it in, we should be done. U times v, 1/3 x squared ln of x minus v du. 1 over x times x squared is x, so I get 1/3 x dx, and that's a really simple antiderivative. So here we are, this is what we do in calculus, we just recopy things over and over and over again. Antiderivative of that, I'm going to need a half, so I'm going to end up with minus 1/6 x squared plus c. There we go. And number 4 we said is an inverse tangent. We have to make this look like 1 over 1 plus. So let's pull out the 2/3, and that leaves us with 1 over 1 plus. If I pull a 3 out of this, I'm going to have 4x squared, and 2x quantity squared gives me 4x squared. So now I've rewritten this like an inverse tangent. Once you get this far, they're all the same. U is just what's on the inside. Du, of course, is going to be something we don't want, so we need to cancel what we don't want, because we must have 1 dx. And then we fill in the blanks and we're done. A half times 2/3 is going to be 1/3. And then I'm going to have 1 over 1 plus u squared du. Inverse tangent and finished. 1/3 inverse tangent of 2x plus c. And we are finished. Oh, I almost dabbed, but I'm going to kink in my neck. I don't want to push it. Alright, so you guys already have your assignment. It's right here. Integral properties worksheet. That's it. We're on a roll. You guys are doing good things out there. I hear good things. People are talking. So keep it rolling. See you guys online. Alright.